Um, my name is Vladimir Ivanov. I work as software architect here at Wrike for 9 years. I came into the company as a junior backend developer when all developers were sitting in a single room. And I grew up with the company and became a software architect. Some time ago, I asked myself, like, how can I achieve the goal of software architect, which is to reduce development costs, actually. And the answer is to reduce the complexity of the system which we are dealing with. And today I want to share with you some of my findings about this topic, which I find interesting and also practical. Uh, in a constantly changing world where speed of changes continue to grow, a lot of engineers work hard every day to creating new systems and uh, expanding existing systems by adding new features. Businesses need new features to be released fast and even faster. The market never stops, and competitors are always there to push us even more. So our systems grow, and with that, systems complexity also grows. But what is it? How does it affect us? Complexity can be perceived as a measure of comprehensibility. It's how difficult it is to understand the system. And with that, it becomes difficult to explain the system, to change the system, to estimate changes costs, to test and debug the system. And with this difficulty grows the time and costs of software development. It becomes more difficult to meet project deadlines, to onboard new people and teams. And if not addressed, the situation leads to more and more synchronization meetings, uh, people frustration, talent churn, resistance to innovation, and eventually systems may fail. But what it's really like, this was the manifestation of complexity, but what is it? Yeah, where is it hide? Does it hide in the system? And simply put, complexity is the function of the number of elements and their interconnections. So the bigger is the system, the more intertwined are its elements, the higher is the complexity with all the consequences. Um, it's far from precise definition, but it's okay for us today. An important note for a software system is that complexity is split into essential and accidental complexity. Essential complexity is about the conceptual model. It's defined by the business, by the real world problems that business solve. And it's mostly out of hands of engineers. While accidental complexity is not required by the business, and it's defined how the code is designed and written. So it's completely in engineers' hands. At Wrike, we actually address both problems now. With product and UX people, we work on simplifying our conceptual model to make the product simple for users and for ourselves. And in engineering, with engineers and with engineering managers, we address the accidental complexity problem, which is the focus of today. So the problem is old. And a long time ago, the approach to solution was formulated. In 1974, the article Structured Design was written with the book with the same title the next year. And the author, Larry Constantine, with his peers postulated that complexity of the system might be reduced by decomposing the system into parts called modules. Thus, the coupling is low and the cohesion is high. And we finally touched the main topic of the presentation, the cohesion. But before diving into it, let's clearly postulate that the coupling is the measure of modules interconnection. Yeah? It's external property of a model, how they communicate with each other. while the cohesion is the intra-modular connectivity, how elements of a module relate to each other. So it's internal property of a model. And modularization may happen on different scales. Yeah, we can speak about methods as modules within a class, classes as modules within a package, packages or Maven modules as modules within an application. And for developers, for engineers, low-level modules are of more interest because they have the biggest impact and because we work with them the majority of the time. So we focus on them today. Again, another important point that cohesion and coupling are correlated. So the greater is the cohesion of individual modules, the lower is the coupling within the system. So on average, when one grows, the other decreases and vice versa. The correlation, of course, is not perfect, but it's rather a hint for us that we probably may focus on only one aspect, not both. So looking at this image, how do you think, what is easier to analyze whether element 4 should be placed in module A or module B, or to analyze that module A and module B should or should not be connected at all? I personally think, and people write books and the industry experience says that thinking about the cohesion, so about where element 4 should be placed, is easier just because the context of this problem is smaller, because you need to think about smaller number of things simultaneously to decide where to put the element. But it's still not clear how to decide. Yeah, what should we pay attention to decide where to put an element? And the associative principle was introduced in the book by the same authors, which postulates that we should find some correlations between elements, as simple as that. Look at this method. It looks weird. It has a lot of responsibilities. We can see database schema in SQL query. We can see configuration config, connection config, low details of communicating with database, some calling of business logic. So a lot of concerns. It's not clear how to test it. It's not clear who's author, who's owner of this code. Why can it break? Can I touch it or not? But still, some things are related here. So we cannot say that cohesion is the best possible, and we also cannot say that it's the worst possible. So the cohesion is not a yes or no function. Yeah, there should be a scale, and there is the scale actually. There are a lot of scales, but I will show you the original from the book again. And let's start. It starts from coincidental cohesion. It's the weakest level. There is no meaningful relation among module elements. It's difficult to understand the logic behind it. It's not clear who might own it. I don't know how to test it. So it's the worst form and should be avoided, maybe except some simple scripts. Next level is logical cohesion. Now we may observe some logic. Elements of this method operate on a book. We can see this cohesion in some utility or helper classes often. Our developers initially wrote this somehow, but with time, such modules become garbage because it's never clear how to change them. What can I put there or what can I not put there? Next is temporal cohesion. It's when elements of a model are executed in the same small period of time during application execution. It's basically the same logical cohesion, but with the logic being the time of execution. Still not good. Slightly better, procedural cohesion. Parts are related. Yeah, there is a sequence of some calls, of methods, and there is a good, appropriate use case when we describe some business process with clear, ordered steps of method calls. And when these are just calls of some interfaces without implementation details, it may survive pretty long in the system without problems. But still, the ownership is unclear, it's unable to reuse, and it has many reasons to change. Communicational cohesion is basically procedural with shared data. Here, the input is shared between all elements, but it might be a database object or output of the method. Here we see some relationship somehow contributing into problem, because we have object of the real world, which is a book. Everything somehow works with the book, so probably it is about some problem. But still, we're not sure. A very strong cohesion level is sequential cohesion. It's when each statement of a method takes its output, gives to the next statement as an input, and they all create a sequence. This sequential cohesion you may see in functional programming, yeah, where they create a good pipeline together. But there is one downside of this level of cohesion. It may contribute to several problems, or to just a part of a problem, or maybe parts of several problems. And when we remove this obstacle, we get the top level of cohesion, the functional one. So the module completely solves exactly one problem. This method is clear, it's easy to test, and it has small number of reasons to be changed. So we have the scale with some scores, and we can say that when module elements are logically associated, executed at one time in a particular order, sharing some data, solving one problem fully, where each element contributes to the problem, well, we got a cohesive module. So we kind of understand what cohesion consists of, but to use it in practice, there is a technique. You take your module and you write a sentence about the purpose of a module. If you can't do anything, then probably it's coincidental, maybe logical cohesion. If the sentence is huge and contains multiple verbs, then probably it's procedural, again, logical. If you can see words like first, last, or init, then it's probably temporal something. When the sentence is short, concise, consists of one verb, you can understand it very clear, and you can explain to other people very clear, then probably cohesion is good. There are also multiple numerical cohesion metrics in industry that allow to calculate the cohesion automatically. Some estimate based of fields or methods reuse, some of data reuse. Static code analysis tools such as SonarQube, Codana, or JArchitect provide the ability to measure the cohesion of the code using these tool metrics. Please raise your hands if you have SonarQube or JArchitect or Codana or some. Okay, do you measure the cohesion? No. Nice. Yeah, and I personally think that the best measuring of cohesion should be semantic. It should integrate the meaning of the code, because it should correlate with the real world problem that we solve in the method. And today, we have a tool that can allow us to measure semantic cohesion. Can you guess maybe what the tool is? Yes, thank you. Um, there is a QR code under there. You could find the prompt. Should put here. Yeah, yeah. The prompt is quite large, and I tested it on several pieces of the code, and you can try it. At Wrike, actually, we are working on incorporating AI analysis into CI to get insights about changes of the code early and directly into the messenger, and with the ability to filter, to subscribe to certain parts of the code base, which are of the most interest. Um, we did not finish it yet, but I really look forward to it. I think it will be helpful because now I use it manually and I really find it helpful. Um, yeah, and I also want to say a couple of words about software design principles. Solid principles, probably everybody knows them. And they also aim at reducing complexity by reducing coupling and increasing cohesion. Robert Martin, this man himself, thought that a single responsibility principle is actually another formulation of high cohesion. And it's natural, like when a model is focused on some small context, on some small problem, then it has smaller reasons of change. So smaller number of actors of real world, teams, people, whoever will need to change it. So the model will likely stay stable. Other principles like open close, least of substitution, integrated segregation, and dependency inversion more aim at coupling improvement by focusing on good contracts. But as I said before, when one aspect is improved, the other is also improved. So it's not really matter where you put your efforts to. The system will become better and better and better. And the last thing to share is that despite coding practices on a low level, large system scale is also very important. Domain-driven design advocates for cohesion on a larger system scale by postulating that modules should be organized based on so-called bounded context defined by business problem context. And again, it's natural that objects of the real world that are close together are conceptually modeled as a closed object and are implemented in the program also as a closed object. Introducing DDD concepts in a given software company is a big challenge. And I don't think that all ideas from the Blue Book should be taken as is. But some ideas are good enough, and I try hard to incorporate them at Wrike right now. So if you want to improve your design skill in order to address the complexity of the systems, I highly recommend reading this book, the Blue Book, as they call it, and the Red Book. It's about more implementation aspects. So which one to choose? It's a very difficult question to me because I love them both. But probably for developers, for practical goals, the Red Book will be more useful. But really, they both are very good. That's it from me. Thank you. And if you have any questions, please ask.
Okay, questions, guys? First of all, thank you, of course.
Yeah, thanks.
No questions here. Oh, over there. Okay, cool.
Yes, thank you so much for your presentation. It was inspiring and insightful. I just maybe not. It's a bit off topic. How did you make these images on your presentation? Maybe you can share your tips and tools.
Uh, yeah, it's ChatGPT, and I like to write long prompts. Actually, that's not a hobby maybe, but I just like to do it. And when you practice it, the images become better and better. And like it's all about the fantasy and the words that you use in the prompt. It's limitless.
Do you mean not ChatGPT, but you mean Dalio? Or what is it?
Well, yeah. For me, it's just a corporate portal.
Oh, okay. Okay.
I don't know the model out underneath. So
Thank you.
yeah.
Anybody else interested in cohesion? Okay.
My question is regarding to DDD, domain-driven design. So, what is your impression? What must be the characteristics of either the system or the team? Like how big the team, or how complex the system, or maybe how large scale the system, like big, like trillions of operations per day, whatever, to really reap some benefits from DDD, because it adds complexity. So my question is, I'm curious, like how big it must be to really incorporate more and more of DDD.
I would say that when the company really starts to struggle from not being able to easily evolve it, communicate about it, like when you see struggles in the business metrics, yeah, when the effective development efficiency starts to decrease, when you start to analyze the complexity, and you can calculate, actually there are numbers, and you see how many classes do you have. Like if you have 100,000 and you don't have any structure that's somehow related to your business domain, then probably you have to do something with it. But I don't think that there is silver bullet answers. You should analyze it and think about it. So probably I don't have an answer for you. But I personally think that it's a good tool, even specifically to decide how to modularize the system. What should be the boundaries of the modules? What should I put inside? And the business domain is the answer.
Hello, I have a question related to the code snippets that you showed. Is this a real production code from the Wrike code base?
And no, they are generated. Yeah, just to visualize the idea.
Thomas?
I'm curious if you do some, let's say, A/B testing, if some team is better than the other in adopting these measures, and if you can see that maybe their throughput is bigger, or it's like if you can go a little deeper into these business metrics.
I'm not sure that I understood the question. Could you maybe reformulate?
Yes, it's like if you work with this cohesion or with architectural principles, some team is probably adopting these things earlier than others, or how do you roll out the change? And if you see that maybe the team's throughput got better, or like how do you see that this thing works? How did you test it?
That's a really good question. Actually, it will be it will show results with time. Like it's a long path, but if you don't pay attention, then the curve is like this. If you pay attention to these practices, the curves start to go like upside. And if there is a team of individuals like enthusiasts in design, you just see that they fast by the regular management metrics that they have. I don't know, features per month or something like that. Like, I'm not a manager, I'm not a specialist in metrics, but I personally push these ideas in several channels. So I talk about them. I've got the architectural blog in a corporate Slack. and I talk to people, and I prepare a document like about code reviews, and I talk to people which aspects are important in code reviews, because even Google review document, the design is like the first, like the functionality, and then the design is like not the code style. Yeah.
Perfect. Yeah, we need to actually go to another topic. Thank you, Vova, again.
Thank you
And
guys.
applause.